Alright, for this lesson we're going to be looking at just different operations that you can perform with functions. Now, I'm actually pretty confident that if you made it this far in algebra that you have done operations with functions in some manner. You've added or subtracted, multiplied, divided. What might be a little different is the notation. So when you get to a college algebra course, a lot of times this parenthetical notation is used over here just as a way to consolidate, okay? So over here, where it says parentheses f plus g, close and then reopen, of x, close, that's just a shorthand way of writing f of x plus g of x. And then likewise for all the other ones, what we do is we put the operation between the f and g, and then we parenthesize the x. Now, of course, out of context, this could look like this is saying do something and multiply it by x. That actually might be the most common mistake I've seen students make when dealing with functions and operations. But you have to know the context. And in the context of speaking about functions, the parentheses x is just telling you that's the variable that is in these two functions. So over here on the left, I've got three functions labeled. I've got f of x, g of x, and h of x. And we can do some of this work numerically. So for example, we can say f plus, whoops, that's not a plus, f plus h of 4. So what that means is take f of 4 plus h of 4. And so I'm going to plug 4 into the f function, that's 2 root 4, plus, and then I'm going to plug 4 into the h function, that's 2 times 4 squared plus 3. The square root of 4 is 2, 2 times 2 is 4, so this is 4. 4 squared is 16 times 2 is 32, plus 3, and that is 39. So f plus h of 4 is 39. Now we can perform these operations with just the actual generic functions, okay, with the formula itself. So we can do, for example, how about f minus g of x? Well, f of x is 2 root x minus, we have to parenthesize, we're subtracting all of g of x, that's x squared minus 1. Distribute your subtraction and we would have 2 root x minus x squared plus 1. And we've generated a new formula for this. Now we're going to do a division one real quick and we'll talk about domain a little bit while we do that. So how about if we had f over g of x? So that's just simply f of x divided by g of x, and there may or may not be anything you can do with that once you have that fraction. There may not be a way to simplify. This is a case where there isn't. So f of x is 2 root x, g of x is x squared minus 1, and we're done. That's the new function. But what about domain over here? So if we talk about domain, remember that's the acceptable x values that you can plug into a function. When you create that new function, the domain is just the overlap of the other two domains. Or however many functions you might be incorporating. Now one note though is watch division by 0, right? So if we're not doing one of the fractions, we don't have to worry about this, but when we're dividing by something, we have to watch this. So if we look at the domain of 2 root x, the domain of that is all x's greater than or equal to 0. We can plug anything that's 0 or more, and we can take the square root of it. For g of x, the domain is all real numbers. You can plug anything in and square it and then subtract 1. When we combine them then, the overlap, so if we're looking at like what does anything greater than or equal to 0 all real numbers have in common, they overlap where x is greater than or equal to 0. So for this one I would say the domain is all x's such that x is at least 0. But wait, there's a catch, because in fraction form we got to watch the division by 0. There's two numbers that would mess that up. One of them's -1, because -1 squared is 1, minus 1 is 0. But we can't take the square root of -1, so we're already throwing that out anyway. But we also can't let x equal 1. So we kind of threw that in as another caution, x cannot equal 1. So there's lots of ways you can appropriately say that. You can say, like I did, x is greater than or equal to 0 except for 1. You could say from 0 to 1, not including it, and from 1 to infinity, not including the 1. So there's various ways, set notation or not, that you can do those domains. So function operations, to me, the most important part here to catch up with is new notation, parenthesizing before you put the x there.